So it's not these three x, y, and z, but there would be other coordinates, which I can't even show you. So that's pretty strange. So you might say, but that can't be right, because I know that, when I tell you where that thing is, I give you three numbers and you can get there. So what happened to the other dimensions? Maybe the other dimensions are curled up so tightly we don't experience them. So instead of living in a three-dimensional world, let's live in a two-dimensional world. So in that same way, in two dimensions, you have to give two numbers to specify where anything is, x and y. Right? So here I live in this two-dimensional world. Here's x, here's y. If I want to tell you where any point on this piece of paper is, you could just give me x coordinate and y coordinate, and I'd find the point. Right? Okay. So now I'm just going to change this space a little bit. Just a little bit. I'm going to turn it into this cylinder. Did I change anything? I mean, if I wanted to specify where a point is on here, what do I have to tell you? Fine. Right? It's x and y looks a little different. If you said x is this.
No, because it's on the cylinder. And it's not anything in here.
Yeah, it's not inside there, just on the surface. So you would say along the axis and around the axis. Two coordinates. So now let me do the following. Let me curl this up really tightly, and I'm going to change my analogy a little bit. Imagine that I'd really, I can't do that well, but I'd really tighten this up, right? So it looks a little bit like a rope. Now imagine that you have a tightrope walker, and you ask the tightrope walker, how many dimensions do you live in? He lives on this rope, right? So as far as the tightrope, so as far as the tightrope walker is concerned, this is a one-dimensional world, right? He can go this way, he can go that way, and that's it. So this, for the tightrope walker, looks like a one-dimensional world. It's a guy on the rope. But to the little bug that sits on the rope, no. This is a two-dimensional world. I can walk along the rope and I can walk around the rope. But the tightrope walker is too big to experience that other dimension, which is the one going around the rope. So from his point of view,
bugs can only experience the
well, really tiny bugs. Really tiny bugs. That's the whole point, right?
Particles can experience the tiny bugs.
Maybe some particles can. Maybe some can't. So, you're falling apart.
I read a book. They had a picture, and it was an ant on a rope, and there was like.
It's the same analogy.
No,
Yes.
no. It was like this. There was a rope like this, and then let's say if you ask the ant to walk from this point on the rope to that point on the rope, you have to walk a very long distance. But what if you put the rope like this? If he walks like that, he's technically walking to the same spot, but it's different.
That's right. And
What is
that's
that
a little bit. Well, that's a little bit of, again, back to Einstein's general theory of relativity, where gravity masses curve space-time. So if they curve them a lot, then that's the kind of thing you talked about, where you might join the two ends together. Sometimes called the wormhole.